Okay, now we're going to start working with derivative rules. Remember, the derivative is a function, right? So let's say the derivative ends up being this function. At a given x value, when you plug an x value into there, say you plug in 2, 3 times 2 is 6, this function produces instantaneous velocity, which is slope of the tangent line. So that's what a derivative is. A derivative is the function that produces instantaneous velocity at a given x value. So we're going to talk about the constant rule, coefficient rule, power rule, product, quotient, chain, and then how the chain rule is applied to trig. We will be doing the basic ones. There are logarithmic ones, exponential ones. There are some others, but we're going to start off with the basic ones. The first one is the constant rule. If you have a constant function, think about it. If you have y is equal to 5, up there at 5, that's a horizontal line. Well, what's the slope of a horizontal line? 0. So in order to have a function whose slope is 0, so let's think about this for just a second. Well, I'll just explain it this way. Every time that you have a constant as the function, the slope or the derivative will automatically be 0. You won't have a 3x or a 5x squared because a horizontal line is just a number and that slope is 0. I mean, the tangent line, well, the tangent line would actually touch that entire line because it's just a straight line. So the slope of a horizontal line is 0. So the constant rule, anytime you have a function equal to number, the derivative is always 0. The coefficient rule. The coefficient rule says that if you have y is equal to 7x, the coefficient you leave, and then you're going to use the power rule. So if we do dy dx, you leave 7, and then you take the derivative of x. So let's see. So notice you leave, so here we have f of x is equal to 3x, and that's x to the first. And in a second, when we're talking about the power rule, you'll see the rest of this. But notice that 3 will stay the same, and then whatever is left, you'll multiply. But you'll see in a minute that what you're going to multiply is 1. So let's do the power rule. So the power rule says this: if you have f of x is equal to something to a power. Now, the power could be a fractional exponent. It could be a negative exponent. It could be a power of 1. It could be a power of 1,000. So you're not limited just to integers. You can have fractional or negative exponents. And here's the rule. If you have x to the n, that n is going to come down in front. Then you're going to multiply whatever that exponent was. And then notice the new exponent is whatever the old one was, subtract 1. So let's say if we have 3x squared, the n will come down in front, and you'll actually leave the 3 out in front, and then it'll be 2x, and then this was 2, so 2 subtract 1, that n subtract 1 is 1. So that's what I showed here. But because the 3 was there, I really should have drawn the 3 there, the 2 there. And then 2 subtract 1 is 1. And then 3 times 2x is 6x. There's the derivative using the power rule. So let's say we have, this is the function. Well, then, so I'm going to use this notation, f prime. And the direction is actually important, so make sure that your little prime mark goes in that direction. So f, that's called a prime. F prime of x means the same thing as dy dx. Y prime means the same thing. It means the derivative. So you bring the -5, there's that invisible one there. You bring the -5 out in front. But remember, -5 subtract 1 is -6. And what does a variable to a negative exponent means? It means x to the -6 you're going to rewrite as the negative front, the -5 stays there, but then we're going to rewrite x to the -6 in the denominator as -5 over x to the +6. So this right here, using the power rule, the -5 came down in front, and then -5 subtract 1 is -6, but x to the -6 is the same thing as 1 over x to the 6th, but instead of 1, we have a -5 in front. Okay, now we have a fractional exponent. We still do the same thing, so f prime of x, we're going to leave the 12 out front, equals, we're going to multiply it by that 1/2, and then 1/2 subtract 1, well 1 is 2 over 2, so that equals -1/2. So f prime of x, left off the prime, well half of 12 is 6, and x to the -1/2 we can rewrite, but remember what -1/2, it means the square root of x. So x to the 1/2 equals this, x to the -1/2 equals this. And those are all examples of the power rule. Okay, the product rule means that you have an f function and you're multiplying it by another function that we're going to call g. Here is the formula, and yeah, you're going to need to end up having this memorized. But we're going to practice it so much, believe it or not, by your Unit 2 exam, you'll have it completely memorized. So you take the original f function, but you multiply it by the derivative of the g function. Then you put a plus sign. Then you take the original g function and you multiply it by the derivative of the f function. So let's do an example. So notice we have 3x squared, I'm going to call that the f function, times 2x plus 1. I'm going to call that the g function. So what I recommend is that somewhere on your paper you state the original and its derivative. It's the g function original and its derivative. So the f function original is 3x squared. So remember, when we take the derivative of that, the 2 will come down in front, and it'll be 2 times 3, which is 6. And then 2 subtract 1 for the exponent is 1. So that will be, that's the original. And then when you do the derivative, you'll have 6x. So remember that whole time when we were doing the difference quotient, where you would have had to do 3x plus h squared minus 3x squared all over h, and all of this stuff here, and you would have done a couple things, and finally at the very end you would have ended up with 6x. Now look how quickly you can do that now because of derivative rules. All right, so here's the original. Let me put the derivatives in blue. And I'll put the g derivative in red. So our original g function is 2x plus 1. Oh, good, I did have it in red. Now remember, this is 2x to the first, so 1 comes down in front. 1 times 2 is 2. 1 subtract 1 is 0, and 0, any number to the 0 power, just cancels to 1. So this coefficient rule, remember when I said back here, you're going to see that when it's just x to the first, the derivative of x to the first is 1. So the derivative of 2x is 2. Remember what the derivative of a constant is? What's the slope of a horizontal line? 0. So I'm going to put that original back in black. Whoops. And then we're just going to follow that formula. You take the original f and you multiply it by the derivative of g. Then you're going to take, you'll put a plus sign. Then you'll take the g and you'll multiply it by f like that. All right. So we have the original f times the derivative of g plus the original g times the derivative of f. And then you just do the distributive. 3x squared times 2 is 6x squared. And then do the derivative here. 6x times 2x is 12x squared. And 6x times 1 is 6x. Well, these are both squared, so you can add those together. Ta-da! So the derivative of the product of those two numbers is 18x squared plus 6x. Using the product rule. Now we're going to do the quotient rule. Okay. The quotient rule is similar, except for now it's the g times the derivative of f. Let me subtract, not add, but subtract the original f times the derivative of g. And that entire thing is going to be divided by the original g squared. So let me give you the original function. I'll call this h of x. Notice we have a rational function, 3 over x plus 1. That divide separates the numerator function divided by the denominator function. So f of x is just a constant function, and g of x is x plus 1. So we're going to take the time. F is 3, the derivative of a constant horizontal line. The slope is 0. And then g of x, x plus 1. Well, remember the derivative of x, x to the first, bring that down front, so that's 1x. And then 1 subtract 1 is 0. Well, x to the 0 cancels to 1. So the derivative of x is 1, and the derivative of any constant is 0. So here is the derivative of g, and then you're going to plug everything in there. So you take the original g, that's going to go first. Here, let's do this. So here is the g function. Here is times, here's the f prime. There's the subtract. Here is the original f, so right here, there's the original f times, here is g prime, all over g squared. So in the numerator, 0 times anything is 0, so that's going to cancel. And then there's a subtract, 3 times 1, so there will be negative 3 in the numerator. So I'll just put the negative in front of the fraction, or you could put the negative in the numerator. It's better to do this. And then when you expand that denominator, remember the Pascal's triangle, 1, 2, 1. The first thing squared plus 2 times the x times the 1 plus 1 squared. So that is the quotient rule. And don't freak out, we will be doing a lot of these together. After about a week of practicing these, you will have those memorized because you'll be doing it. The chain rule is a little tricky because what you have is a g function inside. Remember, the last 2 years when you were doing the combinations, the f of g of x, and that is when you would plug the g into the f. Well, that's what you're doing here. The chain rule says that when you have a composition, here's the rule. You take the derivative of this outside function. Here I should actually take the derivative of the f function and leave, when you take the derivative, leave the g function intact. Just leave it in the parentheses. Then you're going to multiply by whatever the derivative of that g function is. So let's do an example. So here's the formula that I will put right up there. Here, I will make that smaller so we can actually see it. So there's the formula. So notice the 3 blah to the fourth. Think about it this way. 3 something to the fourth. Well, the 4 would come down in front. 4 times 3 is 12. And then 4 subtract 1 is 3. So our next step would be 4 times. Remember what I said, you leave the g. This is the g function. So this outer blue stuff is the f. 3 something to the fourth is the f function. And this inside the parentheses is the g function. So we're going to leave the g function intact. But now we multiply on the outside of the parentheses. So we have our 4 something cubed right there. 3x to the fourth, or 3 something to the fourth. Ooh, what is 4 times 3? 12. So 12, that becomes 12 something cubed. And now you have to take the derivative of 2x squared subtract 5. Well, negative 5 is a constant, so the derivative of a constant is 0. And then this 2x squared, the 2 will come down in front. So 2 times 2 is 4. And then 2 subtract 1 is 1. So the derivative of 2x squared is 4x. And then, so I'll call this h. Since this outer one is f and this inside one, the chain rule produces an entirely new function, and I'm going to call that h prime. So h prime of x, or if you want to put dy dx, that's fine, is equal to 12 in parentheses 2x squared subtract 5 cubed times 4x, and then this outside number, these two outside numbers multiply. 4x times 12, I'm going to actually erase that. 4x times 12, when we multiply this term times that term, we end up getting 48x. And then you leave this in the parentheses cubed. Now, if you wanted to, you could take the time to expand it, and then after you expand it, you would have to multiply all 4 terms by 48x. But this right here, I would allow as the final answer. All right, and then these trig derivatives, you do not have to have memorized because your CWI note sheet will have these trig derivatives on there. I'll just go over that. So if you go over them, if the original function is sine x, its derivative is positive cosine x. If the original function is cosine, be careful, its derivative is negative sine x. If the original function is tangent, tangent's derivative is secant squared x. If the original function is cosecant, cosecant's derivative is negative cosecant cotangent. if the original function is secant, secant's derivative is positive secant times tangent. And finally, if the original function is cotangent, its derivative is negative cosecant squared. I want to point something out. Look at all of these original functions that begin with the letter C. Those are the only ones whose derivatives are negative. So if that helps you remember, it has helped me remember that the only derivatives that are negative, their original function started with the letter C. Just a coincidence, but it's might help you remember. So we're going to do an example of how the trig function falls under the chain rule. So if we have sine 3x squared, well, notice the inside, this is theta. Well, that's on the inside. So the outer function is sine, I should have done that in blue. So sine is the f of x, and then g is the 3x squared. Remember the chain rule. You take the derivative of the outside function, leave the inside g function, and then multiply it by the derivative of the g. So remember what we said, the derivative of sine is cosine. Whoops. So first thing we're going to do is just say cosine and then leave 3x squared in there. And let me rewrite that as red. But now we have to multiply this by the derivative of 3x squared. So when you bring the 2 down in front, 2 times 3 is 6. And then 2 subtract 1 is just 6x to the first. And then it's best practice to bring this in front. So this right here is the derivative of sine of 3x squared. All right. I think that what I've provided you is a couple of practice problems if this video didn't take up all the time of class today. So go ahead and looking at your notes, see if you can do 1 or 2. Tomorrow in class, we'll be doing one of each type together. Or if you needed to pause the video a bunch and it ate up most of your time, that's fine too. Remember, before the end of today, before midnight, you need to submit these notes.